Okay, in this video, we want to find eigenvalues and eigenvectors of the given matrix, which is a 2 by 2. And so what we do first is say 5 minus r and 1 minus r, this diagonal. And 3 minus 1 remains the same. So 5 minus r, 1 minus r, 3 and negative 1 remains the same, is equal to 0. So the next thing we need to do is multiply 5 minus r times 1 minus r, and by doing that we would get, 1 times 5 is 5, negative r times 5 is negative 5r, 1 times negative r is minus r, negative r times negative r is r squared, and then we do minus 3 times negative 1. So minus 3 times negative 1 would give us plus 3 is equal to 0. And next we need to group everything. So we have r squared minus 5r minus r is minus 6r. 5 plus 3 is plus 8 is equal to 0. And lastly, we need to factor this term out. And so we would get parentheses r minus 2 times r minus 4 is equal to 0. And so our eigenvalues would be r is equal to 2 or r is equal to 4. These two are our eigenvalues. So r is equal to 2 or r is equal to 4. And next we want to get the eigenvectors. So we apply the two eigenvalue. So for r is equal to 2, so we take this one right here and we say r is equal to 2. And what we need to do is simply plug in 2 for r. So 5 minus 2 would be 3, minus 1 remains the same, 3 remains the same, 1 minus 2 would be negative 1. And so this is what we get. And the next thing that we need to do is do reduce row echelon form. And so what we can say is we want to eliminate this line right here. We can do that by saying r2 is equal to r2 minus r1. So we take 3 minus 3 and we get 0. Minus 1 minus minus 1, so minus 1 plus 1 is going to be 0. And so we could say 3v1 is equal to minus parentheses minus v2. So 3v1 is equal to minus, and then what we have is minus v2. And so we can say 3v1 is equal to v2. And so an obvious thing that we can say is if we plug in v1 is equal to 1, then v2 is 3. And so our eigenvector with r is equal to 2 would produce an eigenvector of 1, 3 like this, because we're saying that v1 is 1 and therefore v2 would be 3. And so this is one of our eigenvectors. This is one of them for r is equal to 2. Next we will do the eigenvector for r is equal to 4, this one right here. And so we do the exact same thing. We plug in 4 for r, and so we would get 5 minus 4 is 1, negative 1 remains the same, 3 remains the same, 1 minus 4 would be negative 3, and we need to do the reduced row echelon form. And so we could say that r2 is equal to r2 minus 3 times r1. And so 3 minus 3 times 1 is 0. Next is negative 3 minus times negative 1 times 3 would be negative 3 plus 3, so we get 0. And so what we're going to get here is v1 is equal to minus parentheses minus v2. And so we could say v1 is equal to v2, and therefore our eigenvector would be this, 1, 1, because if we plug in 1, then v2 is 1. v2 is 1, then v1 is also 1. So this is an eigenvector associated with eigenvalue of r is equal to 4. This is a little bit more formal than what we wrote for this, but that's all we need to do to solve for eigenvalues and eigenvectors for this 2 by 2 matrix.